throughout the world's greatest scientific achievements and discoveries, there are two sections on the timeline. We have the actual scientists, the smart people, right? On this end. And on the other end, we have the people that like to talk about philosophy. So, when we talk about science, the first guy, the OG scientist, is Democritus. And around 370 BC, he was the first person to come up with a way of explaining the elements and objects on Earth. He used the word atomos, which was Greek for something that cannot be cut, and he used it to explain how every element was made up of an infinite, indestructible amount of atoms. So that's Democritus. Then, later on, there's alchemy, okay? So this is kind of a weird thought process, but basically, alchemy is the concept of being able to turn every metal into gold. So back in the day, gold was literally just worth so much. It was used to worship gods. They built temples, and they built stuff out of gold to signify something that was worth a lot. And every other metal other than gold was seen as an imperfect version of gold. So the idea was that there is some way that we can turn these other metals into gold through a process called alchemy, or the idea of alchemy. And they thought that they needed an object called the Philosopher's Stone. And this idea of alchemy actually led to many of the forms of separation being discovered. Okay, so we talked about Democritus and alchemy. Then we have this guy, Aristotle. Aristotle believed that there were only 4 elements: earth, air, fire, and water. So, as we find out, he's completely wrong. And his avatar way of thinking led to almost 2 millennium of confusion on what to believe in. So, this guy, right, okay, he is considered to be one of the greatest philosophers in the world. But his way of thinking of what the elements on Earth was so wrong, completely wrong. Like, I don't know how this guy has the right to, like, publish and write books about his way of thinking. Like, he ruined so many generations of people because of how he believed Earth, what Earth consisted of. So, okay, we're done with that. We have like we have nearly a 2,000 year jump until anything else is significant happens. And the next thing is vitalism. So, vitalism is the idea that living things are significantly different than non-living things because the living organism has a non-physical element to this. The non-living element being a soul or spirit that non-living things just cannot possess. I think this idea is strongly connected on how we classify things as living, non-living, and dead, because although this idea of vitalism has been disproven, non-living and dead things are very different. So they were basically, they had the idea down, but they came up with the way they thought of it was wrong. So, yeah. Okay. Next is the Foligistan Theory. Foligistan. I don't know if I'm saying that right. I'm going to be honest. I haven't taken the time to look up how it's pronounced. But the Foligistan, I don't know, theory is the theory of a fire element called phlogiston, or phlogiston, that was found in combustible bodies. This theory led to experiments that ultimately led to the discovery of oxidation and oxygen. Okay, let's see. Next, we have this guy, Anton Laurent Lavoisier. Fancy guy. I mean, he's got, what is that, 5-word name right there? You know, if a guy has a 5-word name, you know, like, he's pretty intense. So, and as we see, he actually, like, contributed so much to chemistry. So he's considered the father of chemistry, because a lot of what he thought is used in modern day chemistry. So something a little different than that he did differently than other people was he relied on visuals to prove things instead of predictions and basically jumping to conclusion. He did not believe in just predicting something. He needed to see it with his eyes, okay? So there was actual visible proof that it happened. And he actually disproved the phlogiston theory, and he discovered the law of conservation of mass. So, yeah, good on him for relying on visual evidence rather than what he thought was the reasoning behind things. Okay, Benjamin Franklin, I swear, this guy has to be the most famous historical figure. Okay, maybe not historical figure, but definitely in the scientific context, he is one of the most famous people. So Benjamin Franklin, I know he discovered the 2 electrical charges, positive and negative, and how 2 like charges repel and how the opposite charges attract. Okay, just 2 years later, we have Joseph Louis Proust. I don't know if I'm saying that right, but we'll go with it. He discovered the law of definite proportions. This law stated that a chemical compound will always have the same element makeup percentages. So, for example, salt has a chemical makeup of 39% sodium and 61% chlorine, no matter what is done to it. This is how you make salt. You can also see the same thing in water. I don't know the exact percentages, but no matter what, H2O has certain percentages of each element. Okay, moving on. 12 years. John Dalton. So, this guy has evolved how we see elements for the rest of the rest of time. John's atomic theory of matter included 5 points, which them being that atoms cannot be created or destroyed, atoms can only join in whole numbers, atoms are different elements, atoms of different elements have different weight, and matter is made up of indestructible, indivisible atoms, and all atoms of an element are identical. Although his last point has been proven incorrect, he discovered so much and contributed so much to what we see as atoms. Like, I'll allow him to get one of his ideas wrong, because he already proved so many of them right that it can easily be overlooked. I mean, he did a whole lot for science. Okay, next we have William Crooks. William Crooks found out that radiation was a thing through an object called a cathode ray tube, or a CRT. So a CRT is a glass tube that is void of air and matter and is coated with paint. And when charged with a battery, the paint will glow, showing that radiation is emitted from the battery. Okay, next is, Sir John Joseph Thompson. So basically, John continued on with William Crooks's experiments, and he used charged plates instead of paddle wheels, paddle wheels were used in the CRT, and he used charged plates. So he concluded that the cathode ray was made of negative particles, and he named them electrons. So that's where we get the electron, because of this guy. Ernest Rutherford, whatever. He discovered a way to tell the differences between the three types of radiation, alpha, beta, and gamma. Ernest also conducted the famous gold foil experiment, which tested if alpha radiation could go through gold foil. What he learned from the experiment was that atoms are almost entirely empty space, but just a tiny bit of them contain a small, solid core that was positively charged. On the same year, we'll talk about this. This is just a little tidbit of information. So, Marie and Pierre Curie discovered and isolated polonium and radium from uranium ores, and on the same year, Becquerel discovered that radiation was emitted from uranium ores. Also, Robert Andrews Millikan calculated the mass and charge of an electron, so he backed Sir John Joseph Thompson's idea and was able to give more information onto what exactly an electron was. Stay in full screen. Okay. We have a big skip, and this is actually, I added this person on my own. Carl Sagan was one of the most popular scientists in the late 20th century. He was an astronomer that worked with NASA. He founded nonprofit organizations, and one of his best works was his documentary. He co-wrote the documentary Cosmos: A Personal Voyage, and I think he was an amazing guy, and the knowledge that he gave to us was important. Now, James Chadwick. He discovered that he basically discovered the third subatomic particle, the neutron. The reasoning behind the name of a neutron is because it has no charge and can be seen as a neutral particle. Okay, our last guy on here, I will have to say, might possibly be the most important person of my and many others' lifetime. Bill Nye has done so much for kids. This is honest. Since I was in the 4th grade, he has been an idol to me, supplying easy-to-pick-up science information to millions of kids each and every school year. I mean, I remember watching this guy in 4th grade up to 6th grade. He made science fun. He made kids have an interest in science. And I think this guy, like, him being able to be funny and teaching people at the same time, it's a great skill he has, and I'm so happy that he applied it to science, because honestly, he has motivated so many kids to want to learn more about science. And I'm going to be honest, teachers should seriously be thankful for him. I mean, if you showed up with a Bill Nye video, like, I thought you were the coolest teacher in the world, and I think he's a great guy. So that's our list of the greatest scientific discoveries. Why is this slideshow, this timeline, so hard to control?